Hey guys, today we're going to be discussing on naming ionic compounds. We're going to have two sessions for this video. So our first session will be in regards to regular binary ionic compounds, and the second session will be in regards to multivalent metals in ionic compounds. Alright, let's move on to our first session. Uh, Binary ionic compounds. What does that mean? What it means is that a binary ionic compound contains only two different elements. Alright, now I will better explain this using a diagram. Let's take this diagram right here. Here we see that there are definitely two different elements, one being a metal element, which in this case is M, and the other element being non-metallic, in this case which is B. Alright, keep in mind that the metal element is always listed before the non-metallic element. Let's just keep this in mind, and let us now move on to knowing that a regular binary ionic compound always contains a metal and a non-metal. This we know, but we also have to understand that the metals in a binary ionic compound always range from group 1, group 2, and group 13. This is where the metals in a binary ionic compound always range from. And its non-metallic elements, they always range from what is to the right side of the staircase. Alright, now let us further understand how to write out the chemical formula for a binary ionic compound. So, to write out the chemical formula for a binary ionic compound, we must first determine the charges on the two given elements, and this charge is also referred to as the oxidation number. Now, in order to find the oxidation number of an element, we must use the periodic table. So let's say we're given the metal lithium. Lithium is under group 1, therefore its charge or oxidation number will be +1. So therefore we would have to write it out like lithium +1. Also, in order to write the chemical formula for a binary ionic compound, we must carry out a step which is called the crossover rule. I will now carry out an example to better explain what I just said. So let's keep this as example 1. Alright. Now, in our example, we will say that we must have to find the formula of the compound formed by lithium. So let's write out lithium. And phosphorus. We know in order to write the chemical formula of a binary ionic compound, we must follow these two steps, which is determining both elements' oxidation number and using the crossover rule, which is step 2. First, let's carry out step 1. Let us find the oxidation number of lithium. So now let us use our periodic table. And we know that lithium falls under group 1, and lithium is right here. And if you take a closer look at the periodic table, you will see a +1 to the top right of lithium. Therefore, this is its charge and its oxidation number. So let's take +1 and write it right to the top right of lithium. Next, let us find the charge or the oxidation number of phosphorus. Phosphorus, again, has to be found using a periodic table, and phosphorus falls under group 15. It is right about here. And if you again take a closer look at the periodic table, the charge on phosphorus, or its oxidation number, is -3. Alright, so now that we've found the oxidation number of our given elements, we have completed step 1, and now we have to carry out step 2, which is the crossover rule. The crossover rule is done as exactly as it is said. Basically what you do is just take the charge of lithium or any other element and cross it over to the right side of the non-metallic element. And then you take the charge on phosphorus, which is -3, and then you cross it over to the right side of the metal. In this case, it is lithium. Now, this is going to be written out as lithium 3, because 3 has now been crossed over from phosphorus to the right side of lithium, and phosphorus will now get the charge of 1, which was crossed over from lithium to the right side of phosphorus. Notice how I didn't write 1 here, because we already know that 1 phosphorus already exists, therefore we don't have to write out the 1. Alright, always remember that the cation is always listed first. In this case, the cation is our metal. So lithium will always be listed first. Our metal will always be listed first before our non-metal. Alright, now let's also understand that the charge signs, as seen, plus and minus, will not stay with its number when it is crossed over. It will just be seen as a number. For example, -3 on phosphorus now becomes just a 3 on lithium. So now that we've covered that, we will now move on to writing out a chemical formula in words. Basically, what we do is we take a regular binary ionic compound, which we have right here, and writing out the name is very simple. We just take the name of our metal, in this case is lithium, and always keep the elements in lowercase. Nothing's capitalized. So we take lithium, which is our metal, and follow it with the name of our non-metal element, which in this case is phosphorus. Now the only change that occurs here is that our non-metallic element will always end in IDE. So therefore, lithium, which is our metal, will remain the same, but phosphorus will now become phosphide. Just like that. So basically we see how our chemical formula of lithium 3 phosphide now is written as lithium phosphide, just like this. Remember, there are no capitals when written. And this is the end of our first session. I hope this video helps you. It will help you in the notebook that Mr. Daigle gave us. So just carry out these steps which I've taught you, and this lesson will make it very easy for you to answer any future questions on naming ionic compounds and regular binary ionic compounds. Thank you.